Good afternoon. I'm John Jones, National Technical Landfill Manager for Suez in Australia. So first of all, thanks for inviting me to talk this afternoon about our landfill business, both in Australia and internationally. I'm going to have a look at a wide range of landfill topics this afternoon with a bit of a common theme. Okay. So in Australia, we've got 7 landfill sites. We've got 4 landfills in New South Wales, 2 in Victoria and 1 in Perth. So they're all located around the main urban areas. Quite big landfill sites, total tonnage around 2 million tonnes per year between the 7 sites. Okay, we're going to have a bit of a closer look in more detail at one of our landfill sites in Melbourne now, which is Hallam Road landfill site. This site's located about 35 kilometres to the south east of the CBD. Over the last 10 years, there's been a lot of urbanisation in and around Hallam Road landfill site, and that trend's set to continue over the next 20 years. This picture shows you where the hotspots are going to be over the next 20 years in and around Melbourne for urbanisation and that brings urban encroachment and things to the landfill. It's interesting to see as well the other 2 main landfill sites in Melbourne, the Boral landfill and the Hanson landfill. They've basically got exactly the same challenges as we have in terms of urbanisation and urban encroachment. They're located in 2 of the hotspots as well as we are. Okay, so we've got a short film just showing what goes on at Hallam Road landfill site. The site opened in 1997. It takes between 400 and 450,000 tonnes a year. There's some aerial shots, gives you a good idea of the proximity of the housing to the landfill sites. So we've got literally thousands of houses within about 100 metres of the facility boundary. So that gives you a good overview of the site there. Okay, so this is one of our cells that we've just finished constructing in the last couple of weeks, started putting waste in it in the last week or 2. It's built, of course, to the Victoria BEPM standard. Okay, this cell is 500,000 metres cubed, approximately of void space, costs about $6 million to build. And that lasts us about 12 months. So we build quite small cells and fill them pretty quickly. Okay, you can see the guys here are constructing the cell. The guys there deploying the geotextile layer. So to the right, you can see there's a layer of clay, 1 metre thick layer of clay, the black plastic 2 millimetre thick HDP geomembrane, and a geotextile layer on top of that. The void you can see to the right there, that's the Leachate collection sump, so that'll be lined as well shortly. Okay, on top of the white materials, the geotextile protection layer, and there's the Leachate drainage stone goes on top of that. Zooming across to the waste placement area, you see big Cat 836 compactor compacting the waste, and a D6 dozer pushing the waste. The waste it's covered on a daily basis, 300 millimetres of soily, sandy cover goes on top of the waste every day. It's progressively covered as well during the day as the waste is placed, again to minimise odours, very small area exposed. During peak times, there's a lot of traffic movements at the site. The site takes a lot of direct deliveries, very little transfer station waste, so quick turnaround times, and health and safety is critical there. This is the top of the landfill, so construction on the landfill cap. There's more or less landfill capping and landfill cell constructions ongoing there, almost 12 months a year as weather permits. So as soon as we fill a cell, it's almost immediately capped, and the landfill gas extraction system is put in before the landfill cell is capped. Again, built in accordance with the Victorian BEPM, so 2 layers, clay and geomembrane. Leachate treatment on the site, basic primary treatment, aeration, and then discharge of the leachate to the sewer. And the site produces around 24,000 tonnes roughly per annum of leachate, which we discharge to the sewer. The energy from waste compound at the site, there's 8 engines collecting about 6,000 metres cubed per hour of landfill gas, producing around 6 or 7 megawatts of electricity, which goes into the local grid. The weighbridge facility at the site, all the vehicles are checked and paperwork documented before they come in and out. You can see the public drop-off in the background there. There's a waste education facility at the site. There's regular meetings with the local community groups visiting the site on a monthly basis, CRG community liaison group meetings. The local community kept informed of all the engineering works that are going on the site, especially landfill gas drilling and things like that. Okay, so hopefully that's given you a good overview of the landfill at Hallam Road and the work that's going on there, and some of the issues that we have with urban encroachment, which we're saying is set to continue over the next 20 years at the landfill site. Just to give you an idea of the complaints, a number of complaints at the site. As you can see, back in 2011, 2012, there was a high level of complaints, and to deal with this, we had to completely change the way the landfill was designed, built, and operated. The scheduling of the construction of the cells, installation of the landfill gas system, liaison with the local community, and all those things to try and bring down the complaints to a more acceptable level. It's another good example of one of our landfill sites in a very urban area. So we have a couple of landfill sites in Hong Kong, Nent and Went landfill. So Went landfill, this one accepts around 2 million tons of waste per year. Hong Kong's one of the most highly urbanized and has one of the highest urban density populations in the world. So this is a good example of a large-scale landfill in an urban area. You can see just in the background some of the skyscrapers of Tuan Wan, which are about 3 kilometers from the site. The green material you can see on the landfill is temporary capping. So approximately 80% of the landfill is covered in geomembrane, a temporary cap. And that's to help with two things, mainly odor issues and also leachate management, because there's obviously high levels of rainfall in Hong Kong, so they have to temporary cap the landfill as they go along with geomembrane to minimize the leachate production and any odor issues. On the front of the landfill, you can see there's a port facility, so a lot of the waste is coming from some of the islands, particularly on boats to the facility. And I mean, this is a good example of a valley fill landfill site. Victoria Bepham again says it's highly inadvisable to have a valley fill landfill site, but it seems to be a good example of quite a big valley fill landfill site that's, with clever engineering, is able to operate successfully. And okay. With urbanisation, there's a lot of pressure on old tip and dump site landfills, very old-fashioned landfills with very little management and operation to remediate. So there's especially in emerging countries and in the Middle East, we're finding that there's quite a number of old landfills which have now become encroached on by housing and industry. And as well, the amount of waste that these old sites, uncontrolled dumps are accepting has increased dramatically over the last few years. So this is a contract we had to remediate a landfill site in Lebanon. This is it's quite famous, called the SITA dump site. It's located to the south of Beirut. And basically, one of the main problems they had, the waste was encroaching on the Mediterranean Sea. So you can see there was a huge amount of litter on the beaches to the north and south of this landfill site. There's 1.5 million cubic meters of waste in this old landfill site. Basically a big hill, 55 meters high, of rubbish right on the edge of the Mediterranean. And they were also having major problems with the waste was being carried across the Mediterranean Sea to Cyprus, and it was landing on the tourist beaches in Cyprus, so it was a bit of an international issue as well. The landfill was owned and managed by the municipality of SITA. Okay. Back in 2012, there was a big fire at the landfill site. When you have a big pile of uncompacted rubbish and there's no controls on waste coming into the landfill, then it's a bit of a recipe for disaster, and it's not surprising that eventually caught on fire. At least one good thing, they had plenty of water to put out the fire. But again, when you have a site like this, which is completely surrounded by houses and population, when you have an environmental problem like this, it's a big issue because the smoke from the fire went into the city and caused a lot of problems in the city. So they finally decided after this incident that they had to do something about it. It was no longer acceptable. So Suez was successful in getting the contract for the remediation project, and the work involved, the first stage was very detailed site investigation of the waste mass to determine that obviously there's no records of exactly what kind of waste was on site. So there's a lot of drilling of boreholes, taking samples of the waste. There was Suez had an on-site laboratory, and they were looking at the potential of the waste once it was excavated to generate landfill gas, and all the health and safety issues involved with relocating the waste. The contract also involved building a cell, a proper landfill cell designed in accordance with the European Landfill Directive. It's very similar to the Victorian BEPM or the new New South Wales EPA landfill draft guidance. And also dealing with the local community and the management of the odours and the odour impact, and all that had to be taken into consideration. The project was funded by the government in Lebanon. They got a grant from Saudi Arabia, and it was supervised by the United Nations Development Programme. There was an expert project team was put together for this project from several business units, all from Suez. So the waste characterization and the laboratory setup was done by SITA, which is our research and development establishment near Paris. SITA remediation is the branch of the business unit that looks after these kinds of remediation projects. Safage is Suez's engineering consultancy, and they worked on the design of the cell, the landfill cell. And NOS is No Odours at Suez Environments, which is our in-house odour management consultancy. Robert Kelly, who spoke here last year. And the project basically involved changing from a 55-metre high pile of rubbish to an open parkland area for the local community. The main business unit that had that was awarded the tender was SITA in the Czech Republic. So there's a big international effort on this project. The project it's coming to an end now. They've built the cell, they've moved the waste from the mountain into the cell, and they have the landscaping part of the project left to finish off in the next few months. We've been involved in a few of these projects over the last few years, and we've developed a landfill remediation tool that you can input all your data, commodity prices, looking at the waste characterization. If you relocate the waste, are you going to be able to generate electricity from any landfill gas that you collect from the waste mass, greenhouse gas emissions? It covers all those objects. If there's any possibility of producing PEF or RDF or SRF or any alternative fuels as part of the landfill remediation project. So it gives you a good handle on if you have got a landfill you need to remediate. Is it financially viable? Can you generate any revenue from your landfill remediation project? Right, research and innovation. So I've got some examples of R&D projects that Suez are involved with internationally and in Australia. There's a big trend in the UK and in France. A lot of the landfills are closing now, basically due to economic reasons. So the landfill tax in the UK now is around $160 per tonne, based on today's exchange rate. So, for example, Suez in the UK have 72 landfill sites, and out of these, there's only 15 currently in operation, and they're every year 1 or 2 other sites closes. So a lot of the R&D is focused on post-closure costs and looking at reducing the post-closure costs of closed landfill sites, because it's at this stage quite a big liability for Suez, the aftercare and the post-closure of the landfill sites. So once the landfills are closed, we still have to look after manage the leachate, manage the landfill gas, environmental monitoring and all these things. So if we can do things to accelerate the stabilization of the waste mass, then potentially we can reduce these liabilities. So one of the projects we're running at the moment is it's a 3-year trial on one of the landfills in France. So it's operating one of the cells on one of the closed landfill sites as an aerobic bioreactor. So this involves injecting air into the waste mass and collecting the gas as it's being produced. So there's 2 cells on this landfill site. One is a control cell being operated as a normal anaerobic bioreactor, and one's being operated as an aerobic bioreactor. So as part of this project, they're looking at things such as the initial characterization of the landfill gas, the characterization of the leachate, looking how that is changing over time as it moves into the aerobic phase, comparing the settlement on the aerobic cell compared to the anaerobic cell, looking at the oxygen consumption through the system. Very important as part of this project is looking at the temperature of the waste mass, because there's a high risk if you inject air into the waste, it'll rapidly heat up and go on fire. So very carefully monitoring the temperature throughout the waste mass and in the gases that are coming in and out of this waste mass to make sure that we don't create any environmental problems as a result of the trial. And to get permission to run a trial like this itself, that was a 12-month project with the local regulators to get permission to run this trial. Another one, leachate treatment on closed landfill sites. So there's a lot of them. Landfills are small landfill sites. They have low volumes of leachate, which are pretty dilute. So just looking at cheap and cheerful ways to treat the leachate. One project we're working on in SITA Australia, emissions monitoring on landfill sites using drones. So we're working in partnership with Draco Scientific on this, and they've applied for a grant from the Victorian government. So it's fitting sensors onto drones, flying them over a landfill, trying to see if we can detect the fugitive emissions of methane and landfill gas. So it's kind of a miniaturization project. So we have the technology already to detect these emissions, but it's making that technology small enough so that it can be fitted onto a drone. Another project we're working on at the minute, again related to closed landfill sites, is a leachate pond. So this is a leachate pond. It'll have a flexible floating cover, and the plan would be that in the winter months you store the leachate underneath the floating cover, and then in the summer months you move the leachate on top of the floating cover so that you can maximize the evaporation rates from the pond. You're not collecting any rainfall precipitation and having to deal with that as leachate. You keep it sealed underneath the cover during the winter and then move it up on top of the cover during the summer months. So basically, just to conclude, well, we know the trend of urbanisation is forecast to continue. These landfills have got many years left to run. So that's a challenge we're going to have for the next decade at least. The urbanisation, it does lead to a lot of competing stakeholder needs, particularly with the local community. We have to work very closely with the local community to make sure that we satisfy all their needs. However, the pressure that we're getting from the local community and these stakeholders is driving innovation on the landfill sites. And that's it. Okay, thanks for listening to that.